In this video, we are going to discuss the order of operations, or as I like to say, why Aunt Sally needs excused. If you've had lessons on order of operations and kind of remember it or remember it very well, I would like you to kind of hold that loosely. I'm going to describe it possibly differently than you've ever seen it before, but it's more true to what's actually going on. So first of all, to talk about the order of operations, we need to talk about what operations are in math. Essentially, operations are the things we do, or our verbs. For example, addition. We add things. That's something we do. And then addition has its negative cousin, subtraction. So those are operations. Now, if we take addition and we do repeated addition, that's going to be multiplication. So what I mean by that is if I add 6 plus 6 plus 6, I will do my more, plus 6, then I can express that as 6 times 4, or 6 4 times. So multiplication is repeated addition, and then division is the opposite of multiplication. And then we can repeat multiplication, and that gives us exponents. So for example, if I take and do 2 times 2 times 2 and repeat multiplication, I can express that as an exponent as 2 to the third. And then the opposite of exponents are, they have a couple different names, roots or radicals, but I can use an R either way. So like, your square roots or your cube roots, and those just keep going up. Those are going to be the opposite of exponents. So if I have 2 squared, which is 4, then I can square root it and get back to the 2. Alright, so these are the operations that we will be working with in this class. There are some other operations, but these are the ones that we're going to be focusing on for the most part. And you can think of the order of operations as essentially we start down here with the most sophisticated operation and we work backwards. So we would do exponents before multiplication. We would do multiplication before addition. We would do roots before addition, and so on. So you always start with the most sophisticated operation and work backwards. And what makes it more sophisticated is that it's built on the other one. It couldn't exist without the base operation of addition. And then if you have an operation that's in the same level, you just work them left to right. There's actually some flexibility with this as long as you're really careful about what's actually going on with the operations. But the safe thing to do is if you have operations of the same level, they are worked left to right. So if you have a problem that has both multiplication and division in it, you just work it left to right. If it has, subtraction and addition in it, you're going to do whichever one is to the left and then work on over. Let's look at some examples so we can see how this is working. Alright, so we have this first one here. We're going to evaluate 3 minus 5 squared. Now, the temptation there is to do the 3 minus 5 real quick because it's the easier thing to do. But that's not how we approach math. We always do the most sophisticated operation first. So squaring is more sophisticated than subtraction. So we're going to do that first. That gives us 3 minus 25. Alright, and then we do the subtraction, which is going to give us a negative 22. Just like that. Let's do another one. So we have 2 minus 3 plus 5. Now, subtraction and addition are in the same level in the hierarchy, so this is where we're just going to work this left to right. So we would do the 2 minus 3 first, and then add 5. 2 minus 3 is a minus 1. Just break down the plus 5. And then the minus 1 plus 5 would be a positive 4. Now, one of the things I said when I gave that rule is that there's actually some flexibility with it as far as the left to right rule. Left to right is the safe thing. It's not going to do you any harm. But if you understand that all subtraction is really addition and think of it as such, we can think of this as 2 plus a negative 3 plus 5. And once we write it all in terms of addition, we can add those numbers in any order we want. I can even do like the 2 and the 5 first. That's going to make a 7 plus a negative 3, which is the same as 7 minus 3, which is a 4. I could do the minus 3 and the 5. That's going to give me a 2. Bring down the plus 2, and that'll be a 4. Now, if that just felt really super confusing to you, you don't need to worry about it at all. You can just work it left to right. If all the operations are on the same level of the hierarchy, you just work it left to right. Let's do a part C. Let's say we have 15 divided by 3 times 6. Again, division and multiplication are on the same level of the hierarchy. So we would just work it left to right. The division of 15 divided by 3 is 5, and we bring down the times 6, and that gives us a 30. Now, for those of you that are interested in it, we can associate the division as multiplication of the reciprocal. So what that looks like, and again, this is even more confusing than the addition and subtraction one. I'm just throwing it out there for those of you that are interested in it. If it's confusing, just work it left to right. When we're thinking of division and kind of manipulating this in this way, it's better to think of it in terms of fractions, because and so instead of thinking of it as 15 divided by 3, we'll think of it as 15 over 3. So we'd have 15 over 3 times 6. Now we could do the 15 divided by 3 just like we did in the previous example, get the 5 and times it by 6. But a way to kind of be tricky with the orders, we could do the 6 divided by the 3, or reduce those. That reduces down to a 2, and then the 15 times the 2 equals the 30. When it's written in that fraction form like that, very few people are tempted with messing up the order of operations. Alright, but if you just want to work it left to right, that's completely cool. We're going to do a little bit more complicated example now. Alright, here we go. 3 plus 2 times 4 squared minus 5 times 7. Now you can kind of mine through here and think about what's the most sophisticated operation and then kind of work down. It's safe. But one of the things I would like to do is to encourage you guys to look at this problem like a mathematician would look at this problem. And basically the idea is that addition and subtraction are going to be the last thing that happens, because those are the least sophisticated operations. So if you think of it as addition and subtraction are the last things that happen, it breaks this problem into 3 clusters. So those are our 3 clusters, where the minus sign is associated with the third cluster, because we always think in terms of addition. But basically I have to find the value of those 3 clusters, and then I'll add them together. And so I'm not really mining through thinking about it for operations. When I look at this, I think I need to find the value of those 3 pieces. All right, now the value of 2, it's pretty much already found for me, so I don't need to do anything with it. And then this last guy down here, negative 5 times 7 is a negative 35. And so I can do that multiplication before or at the same time as I work on the exponent in the middle cluster, because they're not going to interact in this step. And I know that they're not going to interact until the last step because they live in different clusters. So in this middle cluster, I want to do the squaring first. I need within each cluster, I have to follow my order of operations. So I need to square the 4 first and bring down the 3. So it's going to be 3 times 16. Now I still have my 3 clusters, it's just 2 of them are already figured out. I just need to figure out the value of that middle cluster, which is 48, and I bring the others down. And then once I have that, then I'm just combining up those 3 numbers, and it gives me a 15. So really, when people who are super comfortable with math look at a problem, they're not thinking in terms of the order of operation precisely. They will fudge things around, because you can do, as long as you're working in different clusters, you can do whatever operations necessary in that cluster, because those clusters won't interact till the very last step. In math, these things that I'm calling are clusters, in math are referred to as terms. Terms are the pieces in the expression that are being added up. That's not the official definition, but that's a good way to think about it. Is terms are the pieces that are being added in an expression. Okay, so that's the order of operations. We have addition, subtraction, multiplication, and division. We have exponents and radicals, and we're going to perform those from the most sophisticated down to the least sophisticated. Now, some of you guys that are super familiar with Aunt Sally and the way that order of operations are taught normally might be objecting because I've left something out. The thing that I've left out that's usually dealt with when dealing with order of operations is parentheses. But that wasn't an accident. Parentheses are not an operation. Again, remember, operations are the things we do in math. We don't do parentheses. They're not a verb, they're a noun. And so while they get included in the order of operations, they're highly misunderstood and actually cause a lot of mistakes because they're not an operation, and it confuses students because they're trying to do parentheses, and that's not something you do. When you insert parentheses in an expression, it alters how the operations are evaluated, but they themselves are not an operation. Parentheses, what parentheses are there symbols that group things and say, think of all this stuff inside these parentheses as one number. So again, parentheses groups things and says, think of all of this stuff as one number. So they change how you read the problem, but they themselves are not an operation. Let me give you an example. Let's say we have 2 and then parentheses 3 plus 5. Now, when anything's glued together in math like this, that's going to be multiplication. So that says 2 times the group 3 plus 5. And the parentheses tell us think of the stuff in the parentheses as one number. Or in other words, think of 3 plus 5 as one number. Well, if you're expected to think of 3 plus 5 as one number, it would be just as easy to go ahead and make it one number. And that's why we're like doing what's in the parentheses first, because if we can get it down to one number, that's how we're supposed to think about it. And so we think about it that way. And then now it's 2 times 8, which is going to be 16. From this step here, when I do 2 times 8 and that makes it 16, I'm not doing parentheses. I'm doing multiplication. So in terms of my order of operations, that's a multiplication step. It has nothing to do with the parentheses. Okay, because you don't do parentheses. All we're doing with parentheses is grinding it down to one number, and then we're on to doing the actual operations that are happening with that one number or to that one number. Okay, let's say we have this guy here, 2 times, the way we would say this in math is 2 times the quantity 3 plus 5 squared. When we say the quantity of, that means we're saying all this stuff down to one number or one quantity. So again, we need to figure out what is, we want to think of the stuff inside the parentheses as one number. And the easiest way to do that is to grind it down to one number. And now within the parentheses, we have to obey our order of operations here. So I need to do the squaring before I do the adding, and that'll get it down to one number. Now I'm going to do this all in one fell swoop in my head. 5 squared is 25, and then that's going to give me plus 8 would be 28. So the problem is 2 times 28, which is 56. So that's how we handle parentheses. It's not that we have to do them first. There's actually ways around doing them first. But we do need to think of them as one number, and whatever is being done to them is being done to everything inside of them. So here's an example of one containing parentheses that'll get people in trouble because they think they have to do parentheses first. So they want to do something with the parentheses first. But again, we don't do parentheses. The parentheses just tell us to think of whatever's inside of it as one number. Well, what's inside of this is one number. So we just need to think of that 6 as a 6. And it is glued to the guy next to it. So that is that's multiplication. Okay, so this is 3 squared times 6. If I wrote it as multiplication or using a dot instead of the parentheses, this is the exact same expression, But now it's clearer that what I need to do first is evaluate the exponent and then do the multiplication. Sometimes I think, it's just my theory, that evil math teachers like myself write it with the parentheses just to trick you to see if you understand how parentheses work and if you're going to do it in the right order. Hopefully this is helpful on unraveling some of the challenges with order of operations. Another challenge with order of operations is just making your brain slow down and consider what you should do first instead of just doing the thing that feels right first. Slow down and think about it. Math doesn't happen left to right. You have to consider what's going on and why. Kind of related to the idea of order of operations is squaring negatives. And this can give students a real fit. So what we're talking about is something like -3 squared versus -3 with parentheses around it squared. And a lot of people in the entire universe want to think that these are the same thing, but they're not. Okay? So the second one is the one that's easier and more intuitive to deal with. We're thinking of all this stuff in the parentheses as one guy, and we're going to square it. So in other words, we're going to take -3 times -3, and negative times a negative is a positive, so that gives us 9. Okay, that feels right. Now, the contrast is this guy, and the reason why this is so hard for us is when we see a -3, we think of it as one number, but it's not in this case. This is the one that we're thinking of as one number. Over here, how you want to think of this is as if the multiplication by the negative is unresolved. In other words, this is the same as -1 times 3 squared. So the multiplication of the negative is unresolved. And writing it like this, and considering our order of operations, we would need to square the 3 first. That would give us -1 times 9, and then the -1 times 9 is a -9. This is really disheartening to folks, but it is kind of a decided on way of denoting these two different things. We need a way to show both of them, and this is just how the notation works. If we go back to the original guys here, another way to think about it, which is kind of the same thing, just wrapped a different way, is basically a negative means the opposite of a number. So if you have $3, the opposite of that would be like to have -$3. So the opposite of -2 is 2. And so when you slap a negative on something, you're taking the opposite of it. Well, this first expression here is asking me to find the opposite of 3 squared. Well, the opposite of 3 squared is a -9. The second expression is asking me to take the opposite of 3 and then square it. Well, if I take the opposite of if I take the opposite of 3, that's -3. And then when I square a -3, I get a 9. So for some people, just thinking of it in terms of opposites is a little easier. It really doesn't matter how you want to think of it. In the end, you just got to understand that these are saying two different things, and remember that that one is going to come out positive and one's going to come out negative. All right, go ahead and try some of the problems and see how you fare on this.